Okay, so my name, of course, I know a lot of you guys, but there's a lot of you that I actually don't know, which is super cool, which means that the alliance is growing, and that's super exciting. One of the things that I actually am going to start off talking to you about is I'm sort of a mover, so you'll already see that I tend to not kind of stay still very often, but hopefully that's okay. I'm going to tell you a little story about something that happened to me about 2 to 3 months ago at UNC. So UNC does a really nice job of trying to get PhD students to sort of think about their long-term goals, right? So try to think about what it is that you want to do with your life. So I went to this workshop, and they asked us, they gave us all a sheet of paper, and the sheet of paper said life path, right? So they asked all of us, take a pencil or a pen and go ahead and draw out what you think your life path is, right? And so a lot of people drew a line that sort of looks something like this. So they drew something that's sort of like this green line that says, okay, I got out of high school, I go to college, and I get a degree, and I contribute to society, and all is good. And then the moderator asked us to go ahead and draw out what our individual life path looked like, right? And so a lot of people drew something that sort of looked like this, right? So they drew sort of this like up and down sort of line, and et cetera. And so we all had to share, which was a bit embarrassing. So they came to me and they said, okay, Juanita, like, what does your line look like? And so my line, I actually I have the sheet of paper and I retraced it for this speech, and my line looks something like this. And so, and the moderator looked at me, of course, you know, I'm from Iowa, I'm already an anomaly, right? I'm in North Carolina. And she was like, I don't think you really understood the directions. And I said, no, I got it. Like, this is sort of the way I describe sort of how I have come about, right? And so we had to label our life path, right? So we had to give it a name. So I wrote down at the bottom the scenic route, that I've taken sort of the scenic route in order to be able to get to my PhD, right? And so everybody was laughing, et cetera, and like, oh, yours isn't that bad, et cetera. But it's not that it's really bad, it's just that it's a different way to sort of get to the end goal, right? And so I will tell you from my own life experience that I'm not what they consider to be a cookie cutter scientist, in that I'm not a person that came out of college or came out of high school, went to college, and everything was great. I struggled a lot, right? So one of the first things that Dr. Rover talked about was my introduction, and she said that the first thing I did was I went to Iowa, right? So I have my little Hawkeye little gear up here saying, okay, I went to the University of Iowa, and I got a bachelor's degree in biochemistry. But what you don't know is that I struggled to get that degree. It took a lot for me to get that degree. It wasn't something that I came out of high school and I knew exactly what I was going to do, and I spent 4 years getting a biochemistry degree and everything was fine. In fact, when I went to the University of Iowa, I'm the first person in my family to even get to high school, right? So I am the first in my family to go to college. And both my parents are Mexican. I come from working class Mexican-American parents, and whoop, whoop, and very proud of that. But at the same time, I had to navigate all this by myself. And I watched them struggle, taking care of us. And so one of the things that I did, a classic thing that I know a lot of students do, not just me, because I talk to other students, is that I wasn't good at time management and balancing sort of school and work. So I was spending a lot of time working in the lab and less time on my studies, and I actually did really poor. So after the second year of my undergraduate at Iowa, I dropped out because I was like, I'm done. And that's not something I'm really proud of. It's a little embarrassing to sort of think about, but I'm sharing this because if any of you maybe know somebody that has done this, or maybe you yourself have done this, I'm here to tell you that you can overcome this, right? So I dropped out for several years, and I worked full-time as a secretary. And I hated it. Not that I have anything against secretaries, but I was making money, I was sending money back home, but I wasn't doing science. And so once I finally got my act together, I decided to go back to school. Things were great. My grades, you look at my transcript and they go sky high, there's awesome. I was doing everything right. And then toward the end of my junior year in undergraduate, my mom was diagnosed with cancer. And at the time, that was a week before finals, and they had given her roughly a year or two to live. She had lung cancer, and she lasted 31 days and she died. And she died 2 days before finals started. And my whole family completely came apart. Emotionally, everything came apart because my mother essentially was the head of the household, right? And so my dad doesn't read or write because he was a migrant farm worker. He dropped out of school when he was 9. So my mother did everything for him. She cooked, she cleaned, she paid the bills, everything. So when she died, the whole family came apart. And so what I ended up having to do was plan a funeral while I was taking finals, trying to keep myself together for my dad because my dad was a mess. And after I got through that, then I spent a good 6 to 7 months after that going home because I was in Iowa City, driving home to Des Moines every weekend, trying to teach my dad how to cook, trying to teach him how to clean, pay his bills, etc. Every single weekend while I'm trying to finish a degree in biochemistry. It's not like I'm getting a degree in basket weaving or something, right? I'm getting a degree in biochemistry, right? Which is really hard, right? So I got my degree, I finished, thank God, by the grace of God, and with honors, and thank you. Thank you. But at that point, I was like, I'm done. I'm not doing any more school. I'm finished, right? I just barely crossed across the finish line. So I knew I wanted to do something sciencey, and I knew I wanted to do something overseas because I had done a study abroad program when I was an undergraduate. So I joined the Peace Corps, right? And so, so I did this really cool experience, and I'm not going to talk a lot about the Peace Corps, but I am going to talk a little bit about it because it is a very important part of my life that really transformed me, right? So I served in a country called Nicaragua, and I'm from Iowa. I had no idea where Nicaragua was. And I served in a town, if you see on the map, a town called Sabana Grande, which for those of you that speak Spanish means big sheet, right? So it was basically a small little village in a plateau in the mountains. I served in a site without running water and without electricity. And so this is my house that I lived in Nicaragua. I actually built this house myself. It's an adobe house with dirt floors. And remember, I lived without running water and without electricity, and I'm from Des Moines, Iowa, right? So the closest I had come to, you know, anything rural was like Living History Farms, you know, or something like that. It wasn't anything like, you know, I'm from the city. Like, I mean, it's a city, right? So I had no idea how to do any of this, right? But I figured it out. I learned how to do it. And I had to learn how to haul water on my head. So this is me with another Peace Corps volunteer learning how to haul water. I had to go to the communal well every day in the morning and at night. And I also learned how to teach because before I went into the Peace Corps, I had a fear of standing up in front of people, a detrimental fear. I just paralyzed with fear. And I had to learn how to teach. So there are, and I know it looks like I'm strangling this girl, but, but I put this up here because she was actually one of my dearest friends, and her mother is in this picture as well. But I learned 2 key things about being in the Peace Corps that I think might resonate with a lot of you. So the first thing I learned in the Peace Corps was really interesting, and it's going to sound weird the way I say it. I learned what it was like to be white. And the reason why I say that is because I'm not white, right? So I'm Mexican, and I went to a Latino country. And it was the first time in my life where I was in the majority. And full disclosure, I really liked it. I liked it. I really liked it. I liked being able to navigate things with ease. I knew the language coming in. I knew the customs. I knew the culture. For the most part, there were things I screwed up a little bit, but like for the most part, there's certain things that you know, right? Everybody looked like me. I interacted with doctors, nurses, etc. Nobody questioned the fact that I was Mexican. Nobody questioned the fact that I got my degree because of XYZ like I get here, right? Everybody looked like me. Meanwhile, my Peace Corps colleagues, most of whom were white, would complain all the time. Oh, they're making fun of my broken Spanish. Oh, I'm not getting good rates on blah, blah, blah. I'm not getting good taxi fares. And the whole time I'm sitting there like, exactly, sound familiar, right? And I remember, I'll never forget, somebody had asked me, boy, I bet you go through this back home in Iowa. And my response was, y'all only have to put up with this for 2 years. I get to go back home to this, right? And I never knew what that experience was like. And I thrived in an environment where there were people that I just didn't question my credentials, right? The other thing that I learned about in the Peace Corps is I learned how to fail. I failed miserably in the Peace Corps. I did so many things wrong. I went in thinking that I was going to do so many different kinds of activities in a community, thinking that I knew the health needs of this community. I was a community health education volunteer, so I thought diabetes was an issue. It's not an issue in where I was living. People were dying, little 5-year-old kids were dying of diarrhea, right? So I was having this sort of Western thinking that my ideas were right, and I learned how to fail. And this idea of learning how to fail has taught me as I go on my life path. So here's where I sort of kind of pick up. So I came back from the Peace Corps, and I ended up going back to school. I got my master's degree in biomedical sciences in Miami, and then in my experience with getting my degree and teaching, and then my experience in the Peace Corps, I decided that I wanted to teach full time. And I felt like I finally found my calling, right? So I ended up at Kirkwood, which was super awesome, and I actually have some of my Kirkwood students here, which is super awesome. They're representing over there like this. But my job at Kirkwood, I became an anatomy and physiology professor, and I didn't realize how much I enjoyed teaching. And the part about teaching that I really enjoyed was being able to sort of connect with students. And this is where I started kind of coming into sort of my own path. So when I was at Kirkwood, I taught for 5 years full time, and I also came into this really cool project called LSAMP. And this is where I became campus director. I started this program at Kirkwood. We started a STEM club, and in this process, as I was sort of evolving, as my life path sort of looks, it's all kind of convoluted, one of my LSAMP students asked me a question when I first started the program, and he said, "Why do you want us to get a PhD if you don't have one yourself?" I was like, y'all, you're not supposed to ask me that. That's not a question you're supposed to ask me, right? And that planted a little seed, and I didn't realize that seed was planted until I started thinking about it, right? So then I had mentors, I had other people that were like, you know, you should get a PhD, and sort of contributing sort of to this little seed. And that's what sort of led me to sort of think, okay, I'm gonna go ahead and I'm gonna go back to school. So I decided to go back to school, and I'd been away from working at the bench for well over a decade. And so I'm not a traditional student. I'm with other students in my cohort who are 22, 23 years old, and I'm not. I'm not gonna say how old I am, but I'm not, right? And I'm thinking, I'm some old lady, I'm gonna try to go back to school and get my PhD. What am I thinking? Can I do this, right? And one of the things that actually came up in a conversation last week, actually, one of my, this person that I know at UNC, I ended up applying to schools. I got into a bunch of schools, and I chose UNC, which was super awesome. And I made this comment to this person about how I was really frustrated. I was not having a good time in the lab, like kind of struggling with my experiments. And I said, you know, I just feel like y'all just let me in just because I was Mexican. Like, I just feel like you just let me in. You just used the race card to just let me in. No, that's not right. You know, I'm sure you know that you got in because of your credentials. And I was like, well, you know, this is just the way I feel. Don't tell me, like, not to feel that way. It's just the way I feel. I want you to just, you know, don't minimize what I'm feeling. And she said to me, I'll never forget, she said she was in the room when they were deciding who was going to get in and who wasn't. And there were 13 other faculty in the room that were making the decision on my application. And she said, the one thing that actually got you in was the fact that you have failed. The fact that you actually, your life, look at this. I'm a hot mess. I'm a hot mess. You look at something like this, and it's just like other students like, oh, they go to college, oh, they go to PhD, they do their postdoc, everything is good. I'm not like that. I am not like that at all, right? And I'm like, who's going to let me in looking like this, right? UNC did. Actually, a lot of schools did, right? And she said the number one reason why is because you failed. And the other reason why that I got in was because of my letters of recommendation. So there is a study that actually came out of UNC. I'm going to make a shameless plug for UNC. There's a paper that just came out in PLOS One. It came out in November of last year, where they actually did a study on our PhD students at UNC looking at predictors of success. And they actually found that the #1 predictor of success, because people use this all the time to let people into PhD programs. They use the GRE and they use your grades. And those are the two things that I knew, well, the GRE score, I did pretty well. But my grades, I'm like, you know, I did all this stuff in undergrad, I was a mess, I got to explain this, et cetera. And I was like, this is gonna kill my application. And they said, my letters of recommendation, and I will always be indebted to the people that wrote my letters of recommendation, because they said, your letters of recommendation are the #1 predictor of your success in graduate school. And your predictors of the way that they predicted success are the numbers of publications that you had and where you published, right? So a lot of students are getting into, they're letting students into schools with high GRE scores and high GPAs, but not necessarily putting out well-publicized, high-impact papers, right? And that the students like me who have failed, who've kind of, I call myself sort of a little scrapper, right? Who have like struggled to get to where I'm at, actually do a lot better, right? And so, and I understand what it is like to fail. So the way I see this and sort of my challenges is, in order for any of us to be successful as scientists, you have to be comfortable with two things. You have to be comfortable with failure, and you have to be comfortable with communicating with everybody. Those are the two things that I firmly, firmly believe. And the reason why I say this is because I study cancer, right? So I study cancer, everything's great, and whenever I tell people this, especially students that are engineering majors or science or math majors, et cetera, they look at me and they're like, oh, I can't help you. Like, I study engineering. That has nothing to do with cancer. And I'm like, are you kidding me? Are you kidding me? So for example, there is a new field looking at the mathematics of cancer. So there's a paper that came out a couple years ago that talks about how they actually look at cells and how they actually migrate within a tumor. And so they did a study. Actually, this paper is pretty cool. If anybody would like to read it, the citation is there. But it's a really cool study that talks about how you can actually use math and how you can actually use differential equations and things to actually help us in this effort against cancer. Cancer for me is very personal. Cancer took the one person in my life, my one support system that I had, right? My mom, right? And cancer has affected me in so many other ways. I have so many people in my life that have been affected by cancer. So for me, this is personal, right? So when somebody tells me, oh, I can't help you, I study, physics or I study math, I say, no, there's a lot, we need everybody in this fight, right? So you can actually do a lot of work with math and cancer. What does physics have to do with cancer, right? There's a lot of things that you can actually use, that we can use physicists for in order to help us understand what is going on with cancer. For example, in physics, there's a new sort of idea of what is called a cellular traffic jam. So if you think about cars that are kind of packed together, and if you get cells that continue to get packed together, they change their shape, or they change their morphology. And how that shape changes affects sort of how the way the tumor grows, right? And so there are physicists that are out there actually studying this phenomenon, right? And so another thing that I always talk about, and I think it's really important for us as scientists to be able to do, is to talk to everybody and to talk about our research, right? So I told you that I come from a family, neither one of my parents went to college. My dad was a migrant farm worker. He doesn't know how to read, he doesn't know how to write, et cetera. So he always asks me, my PI always says, okay, make sure you tell people that what is your thesis, right? So my thesis, if I had to say what my thesis project is, it would be something like this. It would be the mechanisms of oncogene-induced DNA replication stress, right? And to that, I usually put a big X over that because I've had this conversation with my PI, and I'm like, there's no way I can say that to my dad. There's no way I can say this, right? He's not going to understand what this is, right? And I've said this to her, and I've said this to other people, and other people that I've interacted with have been like, well, if people don't understand what you're doing, it's just because they just didn't get a good education, right? They just didn't get a good K through 12 education, and they're just dumb. And I get that a lot. I get it a lot, right? And I get this pushback. And I say, to that I usually say, because I'm very fortunate. I'm going to school, I'm getting a PhD, everything is paid for, right? I've got a stipend, I'm not eating cat food, right? Like, I'm well fed, right? So like, everything's fine. I'm able to pay my rent. All I have to do is figure out this one problem, right? And the reason why I'm able to do this is because of taxpayers, Everybody in this room is a taxpayer. You have contributed to my education. So I owe it to you as a scientist to be able to explain to you what it is that I do, right? And so when somebody comes to me and says, oh, we can't talk to those people because blah, 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 my first retort is, so you think my dad, who mows lawns for a living, who is a US citizen and pays taxes, doesn't have a right to know what I'm doing? Right, exactly, right? So if I had to rephrase this is what I tell my dad. So I tell my dad, I study how cells copy themselves in normal cells versus cancer cells. And he's like, okay, I can do that. You know, I understand that. So I'm going to make a little plug for my lab. So this is some pictures from my lab. The reason why I put this T-shirt up there is because I designed this T-shirt. When I first started I first joined the lab last year. The lab was a very not a very welcoming environment. I'm the first person in the lab that's first generation, and there's really been nobody really like me in the lab. and I'm like, if I'm gonna spend 5 years with you fools, we're gonna learn how to get along, right? Exactly, right? Because they're very stuffy, and we don't do stuff like this. And I'm like, no, like this is not gonna happen, not happening. So I know my PI was like, oh, sweet Jesus, what did I just do? Like I just brought this like crazy Mexican in, whatever, right? So I said, I think let's run a race. Let's do a DNA or there's a 5K race. It's a DNA day in North Carolina. Let's do it. And everybody in the lab fought me on this. We don't do that. We're not a happy lab, blah, blah. I got all this, right? And I went to my PI and I said, I want to do this as a family bonding thing. I know y'all are dysfunctional, but I want to do this. And I told her that. And I said, and I want to design a T-shirt and I want you to pay for it. And she was like, okay, if you design the T-shirt, I will pay for it. So I worked on this T-shirt for a couple months, and they were like, oh, I don't like your designs. Everybody fought me on it. Eventually, I got them all to run in this 5K, which is where we're pictured here and here, right? And they loved it. They loved it. We had a great time. This was in May. In fact, last week, one of the graduate students, one of the ones that fought me on it, he's like, so are we still doing the 5K again? We should do new T-shirts. And I'm like, really? For real? Y'all fought me on this last year. You didn't know what I was doing. We're not a happy lab. Oh, no, I never said that. Oh, yeah, you did. Yeah, you did. Right? Right? So I was like, no. So this year we're doing I'm having to do the T-shirt design again. But that's okay, like baby steps, right? Baby steps, baby steps. Right? So this is me also in the lab. These are people, undergraduates that we have in the lab that are being mentored by another graduate student. So sort of a little bit I just want to say just a little bit about my research because I think it's really cool. So I'll go into a little science part here. So I study cancer, and this slide is really not for any specific purpose other than to show you that cancer usually starts as one cell and it grows into multiple cells. And these cells have a way to sort of stick together. They like friends. They like to sort of stay together as buddies because that's how they survive. Right? And so I study this process. And so what do we actually know about how cancer progresses and how it initiates, right? So the first thing I'll tell you is that cancer is super sloppy, right? And so that, as a scientist, is kind of like it's really hard to work with something that's really sloppy, right? It's a lot easier for me to kill something that I already know the pathway. But when someone is like changing the goalposts all the time, it makes it really hard as a scientist to be able to fight this disease, right? So cancer is sloppy. The other universal thing to also keep in mind as a scientist is that every cell in the body has to duplicate in order to survive. It has to, including cancer cells, right? So that's the one thing that I have to keep in mind. These cells have to duplicate, which means that I need to look at certain things in the cell cycle as to how they actually duplicate. The other thing that I'm looking at is a phenomenon that's called replication stress, right? So all of our cells, when they copy, they have to copy the DNA, and that DNA, sometimes there's mistakes when that DNA is copied. And this is what we call replication stress, right? And so there are certain hallmarks, certain signals that get initiated in the cell that we can look at. Right, so I'm using these to my advantage. So essentially what I study is I joined a cell cycle lab. The lab that I actually joined does not study cancer. I'm the only person in my lab that actually looks at cancer. So I went specifically to this lab, and everybody fought me on this. My PI was like, well, I study the cell cycle, I don't know anything about cancer. If you want to join my lab, we would love to have you, but you're going to have to drive this project yourself because we're experts in the cell cycle, but you're going to have to pull your weight with cancer. So it's pretty cool because she allows me a lot of autonomy, right? So this is a cell cycle. Most of you have seen this. If you haven't, it's pretty cool. This is a picture of sort of like how the cell copies itself. And I will tell you that over here, you see this is supposed to represent just one copy of DNA. And over here, this is supposed to represent 2 copies of DNA. So by the end of S phase, you should have 2 copies of your DNA getting ready to divide in mitosis, right? And so there's 2 things that are really key to my project. The first thing one of the most important things is that your cells undergo cell division roughly a little over 1 billion times in one day. So as you're sitting here listening to this talk, et cetera, y'all are undergoing cell division, right? So which is super cool, right? The other thing that's really important, and I think about this at night all the time, is that our cells, in order to copy the DNA, we have to copy that DNA once and only once, and it has to be precise, meaning it has to be exactly the same way that it was before. No mistakes, right? And so what I study is that actually I look at what are called proto-oncogenes. So these are genes that essentially regulate the cell cycle, that make sure that this process takes place fine. And when these proto-oncogenes become mutated, they become oncogenes. And oncogenes are essentially genes that can cause cancer, right? So here is the essential, my hypothesis for my thesis. So my hypothesis is this idea that we know that oncogenes can cause this idea of replication stress. We know that you get a gene that is an oncogene that causes cancer, and we know that it disrupts how it is that the DNA copies itself, right? So here's a proto-oncogene, totally fine, happy, et cetera, normal gene. It becomes mutated or altered and becomes an oncogene. What we also know is that when it becomes an oncogene and it turns on, you get a DNA replication stress response. So a classic example of this is, some of you may have heard of the gene called BRCA1 and BRCA2, right? So these are genes that we all have. All of us have these genes, BRCA1, BRCA2, and they're fine. Except in some people, that gets mutated, and it leads to breast cancer. It can lead to breast cancer or ovarian cancer, right? So this is essentially what I'm studying. I know that when you turn that oncogene on, you get some sort of replication stress response, and you can measure it. What we don't know in the field is how this happens. We don't know how this happens. And that's where I come into play. That's where the crazy Mexican comes into play, right? So I'm like, I'm going to try to figure this out, right? So what could be happening, right? For example, you could have the DNA might have been affected by this thing called ROS, which is reactive oxygen species. Maybe something's happening to the DNA that's leading to some sort of a response. Maybe, for example, when the DNA copies itself, you have problems in the actual replication fork in S phase. Maybe, for example, there's not enough nucleotides around for the DNA to actually copy itself. Maybe it's something else. Maybe it's a combination of these. Maybe it's all of them. We don't know. This is something that the field does not know. So what I think is happening is I think some oncogenes are targeting G1, right? So replication takes place in S phase, which is when the DNA gets copied. And I think what's happening is something is happening in the phase prior to that, which is actually leading to this idea of this replication stress. And so this is it's really complicated, but you don't really have to focus on the whole thing. What I'm really interested in are 3 oncogenes: cyclin D, cyclin E, and cyclin A. And every single one of these oncogenes you have in your cells. You have them all, and they're fine. But when they get turned on, if they get mutated or altered, this is what can lead to cancer. All of us have these genes, right? And so this is what essentially that I'm trying to study. And so I'm actually studying a very specific event that's called origin licensing, right? And so this idea, here's a G1, here's your DNA, everything's fine, you're trying to copy itself, and you have these little helicases that come up that are called MCMs, and they open up the DNA in S phase, right? So in S phase, this opens up, and you copy your DNA, right? But what I'm trying to do in the lab is there's 2 caveats to this. You can only add MCM in G1. You can only have this process taking place in G1. And if you don't give the cells enough of this MCM protein, then you're going to have problems copying your DNA, right? So this is essentially what I am trying to study. And I'm trying to study this idea, and I'll just sort of give you a preview of this. I'm trying to study this idea of what's taking place at the bottom of this slide. That if you don't give cells enough MCM, you don't give enough cells enough time to copy, you'll rush the cells. And if you rush the cells through replication, they're going to start getting DNA damage, right? So this is essentially my hypothesis for my grant that I just wrote. And that I think that where we need to target our efforts are in G1. And sort of this idea of looking at how oncogenes actually cause replication stress. And this is sort of my background that I have with this, okay? And so this is just an example. For example, I actually created this cell in the lab. So I created a cell that's a regular cell cycle cell, and I put an oncogene in here, cyclin E, and I mutated it. So when I mutated it, it caused cells to divide really, really, really fast. And if cells are dividing really, really fast, they're not getting enough time to copy their DNA. And as a result, like I said, we created this idea, and I got these different cell lines. Now, this next slide I'm going to show you, just to kind of wrap up here with my research, is I don't show this to sort of overwhelm you, but I want you to sort of I want you to kind of see this. And you don't have to understand everything on this slide. But the reason why I show this is because I took a lot of heat when I first proposed this project. So I started proposing this project to my thesis committee. And they said, there's no way that you can create a cell line, and you can create 6 cell lines, oncogenes. You can create these cell lines that actually create cancer. You can't do this in a thesis project. You can maybe do like maybe 1 cell line, but there's no way you can create 6 of them, right? And I actually did all this in 3 months. And they told me that I couldn't do it. And I'm not a person that takes that lightly. I don't like it when people tell me I can't do something, especially when I'm not the cookie cutter scientist that I told you that I'm not, right? And so there's this idea that like if you say you can't do something, right, then you should be able to like, okay, just fine, just roll over, right? And so one of the things that I felt that was really important to sort of kind of convey is this idea that I can do this. I created these cell lines, and I'm actually getting really cool data. I'm in the process right now of publishing my first author paper, which is super awesome. So yeah, so that's super cool. With my PI, we have sort of big plans of kind of putting it into a high impact journal because nobody in the field has started thinking about this idea of looking at events in other phases of the cell cycle, right? So there's a couple things that I sort of want to wrap up with this idea of as being scientists and how you can actually communicate with the general public, right? So the first thing that I want to bring up is this idea that society has a general mistrust of scientists, especially now. Especially now. We've got all this talk about fake news and blah, 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 and scientists. And so a lot of the work that I do, people are like, oh, nobody's going to understand that. You know, you don't have to talk to the general public about that. Just focus on your research, just do your work, and just suck it up and do it, right? And I disagree. And this is one of the reasons why I go out and I talk to high schools in North Carolina. I talk to community groups in North Carolina about not only about the Peace Corps, but I also talk about what I do and what it's like to be as a scientist. I'll share with you just a quick story. I generally do this thing called Skype a Scientist. I don't know if anybody's ever heard of it before, but I do this called Skype a Scientist. And I Skype a rural North Carolina high school, rural. Let me just preface, it's rural. And so I've been Skyping with them, and I met them for the first time. They wanted to meet me in person, so I showed up to the class in December. And I did 3 classes. The first class I did, there was a student in the class, and I said, okay, hi, my name is Juanita Lima, blah, 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 blah. And he raised his hand, and he said, you are the first Mexican I've met other than being at Walmart. And I'm standing in front of the class, and I'm like, oh my God, like, what do you say? Like, what do you say to that, right? And so, do I pull the beast out of her cage? You know, like, what do I do? Like, do I throw down? Like, what do I do, right? And I'm like, okay, I got to put on my teacher hat. This is where my Kirkwood teaching hat came back in, right? So I put on my teaching hat, and I said, I was really, you know, kind of funny, and I was like, you know, we're everywhere. We are everywhere, right? We're just not at Walmart. And I said, we're at Menards too. You know, he's like, oh, really? You know, I was like, and we're scientists, right? We actually do really cool research, right? So that was the first class. The second class had asked me, I said, oh, you know, they asked me what my dad did. And I said, oh, my dad mows lawns for a living. And they said, you can make money doing that? Like, that's what he does for, like, what else does he do? Doesn't he have a real job? That is his job. He's been doing that since I was a baby. I mean, that's what he does. He still does it. 77 years old, and he's still mowing yards, right? And he's pretty good at it. So that's one thing. The other thing that I want to emphasize is this idea that all of you, especially underrepresented students that are scientists, all of you have a very, very interesting and very enriching story that you should tell. Right? There's a lot of shame in what I've been able to tell you today because my life path is such a mess, and I've struggled. You know, I not only struggled when I was an undergrad, but like I have a sister who was murdered by a gang in Chicago. I've had health issues, lots of health issues. I've had a lot of stuff, a lot of just really bad stuff happen. And I'm here. Right? Maybe it's just because I'm stubborn. Maybe it's because I don't know any better. I don't know. But I think what I'm doing is pretty cool. I think I'm sort of meant to be here. I want to do research. I want to be a PI. I want to help mentor students and teach and sort of move the field forward. And all of you have contributions that you have to society. Whether you like it or not, or whether you think it's not valuable, it is. It is. It's what makes you who you are. Right? So the idea that I want to kind of leave you with, some last minute ideas, is you want to, when people tell you you can't do something, you have to sort of train your mind to sort of be stronger than other people or other things, right? You have to, right? And if it means sometimes the people that support you are not always going to be in your corner, right? So sometimes your family can be your worst enemy, right? I mean, I will speak from personal experience. This is an issue for me, right? This is a huge issue. And I am to the point now where I've got some of my IMSD underrepresented students that are in my cohort, they've dropped out because of family issues, pulling them back and forth home, and they're like, I'm just going to give up on this PhD, I'll just do it later. And I'm sitting here running, and I'm like, I worked so hard to get here. Right? And I have 3 letters of recommendation. These 3 people believed in me enough to go out of their way to write me a letter of recommendation to get into a PhD program. I'm not going to let them down. Even if it means I got to turn my back on people that I really don't want to turn my back on. So that's one. The other thing that I want to leave you with is that whatever it takes for you to be successful, you got to get rid of any toxicity you got in your life. Anything. Any negative influences, no matter what. Because if you really want this, and if you really want to make a contribution to science, which I think you should, right? You should surround yourself with people who you know are going to support you, right? You should surround yourself and leave out everybody else, no matter who it is, right? And it's hard. I'm not saying that this is easy. It hasn't been easy to just walk away from people, like just cut them off and ghost them. I've done that a lot. And I've had to, just because I need to focus on this cancer problem. Right? I'm super close to figuring this out. And y'all are going to like come at me, oh, I need money, I need this, so-and-so's in jail. No, really? Really? Like this is like, I don't need to deal with this mess. If it means I have to focus, then so be it. Right? So you all deserve better. Right? So I want to just make a couple of acknowledgments, obviously, to LSAMP and to the lab that I work in and my funding. And I also want to make a shameless plug for UNC. There are 2 podcasts that I would highly recommend that you all kind of get into. The podcast that's much more established than this other one is called Hello PhD. It's on Apple, iTunes. It's a podcast that talks about different issues of PhD students. My friend actually just started this new podcast that's called Straight from a Scientist, and he's looking more at a diverse perspective. And it's really interesting because he's white. And so I'm like, what do you care about minorities for? You know, like, what's your skin in the game? And he's just like, you know, it just meant more to him to sort of get more people sort of in this dialogue. And so I told him that I would make a little plug for him. So anyway, so if you all are interested, I would highly recommend that you plug into these podcasts. And I'll be happy to take any questions.
So we do have time for questions. I'll hand the mic around, and then 'cause we'll be setting up in here, and we'll be able to still get into our panel by about 1:15 or so. So feel free to ask questions.
I'm going to call you Dr. Limas because you're about to get your PhD.
Thank you. I appreciate it.
I'm serious. If you put all those papers in, then you already have first author, so you can graduate.
Yeah, I appreciate
So I was
that.
going to ask you first a career development question. The first one is, what's your next step? It seems like you're able to communicate with the public about science, and you teach extremely well. So are you going to stay there in North Carolina and do the SPIRE program? So that's for you to think about. And then the question for the audience is, I don't think everyone may know so much in detail about IMSD. Some places it's called like IBA,
Yeah.
or other
Yes.
places it's called something else. Could you explain in detail what
Absolutely.
IMSD does for the student that's in graduate school
Yep.
or undergrad?
Be happy. Did everybody hear his question? Everybody heard it? Okay. Question number, first part of your question, yes, I know what I would like to do. I've looked at the SPIRE program at UNC. I'm looking more of an academic postdoc, so I really would like to teach at an R01 institution if I can. But I have been approached actually by the SPIRE director at UNC already. I was approached in my first year, and I was like, I don't even know what this is, and I got to get through a PhD, so I've thought about it. My next step is, once I graduate, I will be pursuing a postdoc. I'm going to try to change fields, because they recommend that you change fields to be able to market yourself a little bit better, to get a position at an institution. So my eventual goal is to have a job where I can teach, mentor students, and run my own lab. And if I run my own lab, which I plan on doing, I'm definitely going to try, well, I'm not going to try, I am going to include the community college in my lab. So I want to make sure, I didn't go to a community college, but people in my lab talk smack about community colleges all the time. They used to, they don't do it anymore because I shut them down. So, and then number two, IMSD, it stands for, it's an initiative from the National Institutes of Health, or NIH, and it's called Initiative for Maximizing Student Diversity. In some schools, they call it a little different. But essentially what it is, it's money that NIH has directed towards schools with the goal of trying to increase numbers of underrepresented students in the STEM pathway. I don't like to use the word pipeline, but I like to use the word pathway instead. And so some schools have a undergraduate component of IMSD, some schools have a graduate school component. At UNC, we have a post-bac and graduate component of IMSD. But I know Iowa has the IBA program, which is super awesome. And they have undergraduate and graduate. So ours is a little different. So.
Hi, really specific question, I guess.
Yeah.
You had the opportunity to attend a couple different PhD programs. You mentioned I was just wondering what it was that made you decide on UNC. It's kind of on the other side of the country and things like that. So I was wondering what was the decision-making process behind that.
Great question. I actually was on the fence between two schools. I was on the fence with Indiana and with UNC, and people at UNC are very, why are you considering Indiana? It's like a Midwest school, kind of like the flyover state. You guys heard that? And and actually this is sort of a side note, if anybody is applying to graduate school and if you're on the fence with schools like I was, most schools have extra funds to bring you back. And I didn't realize that. And I really didn't realize it until I said, I'm on the fence, I don't know what I want to do, I don't know which school I want to go to, and UNC was like, we'll give you money, we'll pay for you to come back. We'll give you a second visit. Y'all are going to pay for me to come back, like for free? Like I don't have to pay for it? Yeah. So, and Indiana, same thing. Who are you on the fence with? UNC, oh, we'll pay for you to come back. So I went back, but I paid for it on my own because I felt bad taking money a second time because I was like, if I get money from both schools and then I end up choosing the other school, it's kind of like I just didn't feel right. So I forked out the money myself. And I went back to both schools, and UNC was the school that I felt like was going to push me more. They have the #2 pharmacology program in the country, so that was big for me. And I knew it was hard, but I went there knowing it was hard. I wanted somewhere where I was not going to be a baby scientist. I wanted somewhere where I was going to be pushed. And so right now I'm doing a lot of complaining. a lot about what I'm doing, but I keep thinking, okay, Juanita, you did this because, you want to be a good scientist. So I felt like UNC had the resources as well, and a lot of it had to do with their IMSD program. To be quite honest, they have a phenomenal ISD program, and I felt like I was getting support there, and I don't regret it at all. So, plus, it was North Carolina, but I'll try to ignore the fact that it's pretty there, so it's pretty. It's pretty, so,
Other questions?
yeah.
Okay, thank you.
All right.
Juanita.
You're welcome.